Elon Musk has a strong track record of proving skeptics wrong on rockets and electric cars. Yet, his latest plan to launch massive artificial intelligence data centers directly into orbit is facing serious questions from thermal engineers. Unlike his past successes, space computing relies on unproven technologies in an environment with zero atmospheric cooling. To keep dense, power-hungry processors from melting in orbit, he must overcome the harsh physical reality of a vacuum. Because space is a near-perfect vacuum, it acts as an absolute thermal insulator. This means that even though outer space is extremely cold, there is no physical medium to conduct heat away from hot server components. On Earth, convection is the dominant cooling mechanism, moving heat quickly via fans and coolant pumps. In the vacuum of orbit, convection is entirely absent, forcing systems to rely exclusively on thermal radiation for cooling. Thermal radiation is governed by the Stefan Boltzmann law, where heat dissipation depends on the surface area and the fourth power of temperature. This makes radiating heat highly inefficient for dense, delicate silicon chips. Without convective heat transfer, high-power server racks running intensive neural network training would overheat in seconds. The accumulation of thermal energy would rapidly exceed safety margins, causing the silicon processors to degrade and melt. To dissipate the heat of a standard server cluster, satellites require giant cooling structures. The radiator surface area needed to reject heat in space is hundreds of times larger than the physical size of the servers themselves. Adding to the thermal crisis, orbital servers are exposed to intense solar radiation. While the sun provides a powerful source of electrical energy, it also injects massive amounts of heat directly into the spacecraft structure. For power generation, space has a massive advantage. Solar panels in orbit receive constant, unfiltered sunlight without day-night cycles or atmospheric interference, generating a highly reliable stream of clean electricity for the processors. To solve the thermal crisis of a monolithic server, engineers are proposing a distributed architecture. Instead of launching one giant data center, the workload is spread across a mesh of thousands of small, low-power satellites. In this mesh constellation, each small satellite only handles a tiny fraction of the calculations. Because each node generates a minimal amount of heat, the individual thermal signature is low enough to be managed by small radiators. However, a distributed network introduces severe computational bottlenecks. Large artificial intelligence models require massive data exchange. Splitting these models across satellites means transmitting data over vast distances, introducing heavy latency. Furthermore, inter-satellite communications rely on laser links, which have limited bandwidth compared to ground-based fiber optics. Synchronizing model weights across orbit slows down the training process, making deep learning highly impractical. When compared directly to ground data centers, the performance of an orbital mesh is incredibly weak. Terrestrial facilities benefit from direct liquid cooling and high-speed local networks, allowing massive parallel processing at scale. Because of physical constraints, the cost of space-based computation is estimated to be over 100 times higher than on Earth. For practical commercial use, space servers are financially and operationally unviable. If the physics and economics of orbital computing are so unfavorable, why announce the project? The answer lies not in engineering, but in the strategic financial valuation of Elon Musk's corporate empire. Musk's companies form a highly integrated network. SpaceX provides heavy launch capacity, Starlink offers laser communication grids, xAI builds the neural networks, and Tesla designs custom hardware and autonomous software systems. By branding xAI as a space-capable technology provider, Musk can inflate the perceived value of his companies. High valuations are crucial for attracting venture capital and maintaining investor confidence in future growth. These inflated valuations justify massive intercompany contracts. For instance, xAI can pay SpaceX for orbital compute delivery, effectively circulating capital between entities to support cash burn and satisfy debt requirements. This financial loop serves a grander scheme, paving the way for a potential future merger or consolidation. By binding these separate companies under one technical narrative, Musk solidifies his unified empire. Ultimately, the orbital AI server project is a brilliant financial narrative, but a terrible engineering proposal. In the real world, the laws of thermodynamics will always defeat the promises of corporate marketing. While space computing might remain an orbital fantasy, the financial gains behind it are very real. If you enjoyed this video, please make sure to subscribe and leave a like. See you next time.